From Cape Canaveral Air Force Station in Florida, you're watching live coverage of the launch of the SpaceX Falcon 9 rocket and Dragon capsule. Good morning, this is Falcon Launch Control at T-minus 1 hour, 6 minutes, 35 seconds and counting. And just about 24 hours ago, the Falcon was fully fueled and ready to soar into space on a 2-day race to the International Space Station when a weather system spanning from across the northern Gulf of Mexico to east of the Florida coast brought torrential rain and thick clouds to the Space Coast and caused a postponement of the SpaceX Commercial Resupply Services 4 mission. Everyone across the country has regrouped, and the SpaceX launch control team here at Cape Canaveral has gathered again to oversee the launch of Falcon and the Dragon capsule. Teams of engineers and flight controllers also are gathered at the SpaceX Mission Control Center in Hawthorne, California. They're overseeing launch preparations as well as the flight once the launch occurs. And the same thing is occurring at Mission Control in Houston at the Johnson Space Center, where Scott Stover, the flight director, is overseeing his Orbit 1 team of flight controllers, awaiting anxiously the launch of the Falcon on its way to the International Space Station. This is the fourth of 12 planned commercial resupply services, or CRS missions, for SpaceX, following 3 previous official resupply missions, the last one in April. Liftoff is targeted for an instantaneous launch window that has been further refined. It's now 1:52 and 3 seconds a.m. Eastern Daylight Time. And at the time of launch, the International Space Station will be flying at an altitude of 262 miles at 51.7 degrees south latitude, 165 degrees east longitude, southwest of New Zealand. Weather today is a marked difference than it was last night. At about this time last night, we were facing 90% no-go criteria. Today, U.S. Air Force 45th Weather Squadron Weather Officer Mike McAleenan has just modified and amended his forecast, giving us only a 10% probability of violation and a 90% chance of favorable weather. They only concern the cumulus cloud rule. Mike McAleenan will be updating the launch control team here shortly, at 1 hour away from launch, in about 4 minutes, so we'll stand by to find out if there are any updates. This is an important mission for NASA and the space station program because Dragon is carrying more than 5,000 pounds of supplies and payloads, including materials that will support the 255 science and research investigations that will occur during expeditions 41 and 42. Dragon has 3 powered cargo payloads in its pressurized section and 2 in its unpressurized trunk. There's a very diverse set of science payloads aboard Dragon. Some will enable model organism research using rodents, fruit flies, and plants. A special science payload is the ISS Rapid Scatterometer to monitor ocean surface wind speed and direction. Several new technology demonstrations aboard will enable bone density studies, test how a small satellite moves and positions itself in space using new thruster technology, and use the first 3D printer in space for additive manufacturing. The mission will also deliver IMAX cameras for filming during 4 increments and replacement batteries for the spacesuits. With a launch on time today, the Dragon capsule should arrive at the International Space Station Tuesday at 7:04 a.m. Eastern Time. The launch team is not working any significant technical issues at this time, and once again we'll be standing by for a weather briefing in about 2.5 minutes from Launch Weather Officer Mike McAleenan. At T-minus 1 hour, 2 minutes, 20 seconds and counting, this is Falcon Launch Control.
OSM, this LC on the countdown net.
OSM.
Can you confirm you have control of the Northeast Lightning Tower camera?
Roger. We have control.
Copy.
This is Falcon Launch Control at T-minus 1 hour, 30 seconds and counting. The countdown has proceeded well to this point. Managers are preparing now to hear a weather briefing from U.S. Air Force 45th Weather Squadron Officer Mike McAleenan.
This is the LWO with the range weather briefing at L-1 hour. Looking at the enhanced infrared satellite picture, you can see the Florida Peninsula is virtually free of any low-level clouds. We see some jet stream clouds moving from basically Tampa to Daytona. None of these clouds are a concern for liftoff. Zooming in a little closer, you can see these clouds are really drying rapidly across the center part of the peninsula, and using the tool to show the direction of travel for the upper level clouds, we are clear of all clouds moving into the launch area. Looking at the radar picture, you can see there is some clouds off to our north and east, and that is association with a low that has developed offshore. Those clouds continue to rotate around this elongated low and are making most of its progress towards the north and east. Do have a little bit of a line of cumulus clouds that are about 15 miles to the north of the launch complex at this time. These are very low top clouds and are a very low threat for any launch commit criteria violation. Looking at the upper level winds, we're seeing good consistency in the last 3 balloons with fairly light winds over the pad through 20,000 feet of less than 20 knots. Maximum winds are about 40,000 feet at about 48 knots out of the west-southwest. So needless to say, we are go on all launch weather commit criteria and expect to remain so for the remainder of the window. Current forecast, it calls for just a scattered level clouds at 3,000 feet and some of that cirrus at 20,000 feet. A good visibility. Winds will stay out of the northwest at 8 to peak 12. Temperature 73 and only a 10% chance of a violation for the next hour. That is a cumulus rule. But again, it looks like that line is very low topped and not a big threat. That's all I have, pending your questions.
LWO, there was a view earlier that showed kind of depicted some blue over the Cape. It wasn't shown during this 1 hour brief, but it's come on periodically. It sounds like that's also maybe just a high sensitivity setting. Yeah, exactly, sir.
This one, okay, yeah, this is the Melbourne radar, and it is not reflecting clouds. It is clear air at some anomalous propagation.
Copy. LD, no questions. Thank you.
Yeah, thank you.
So virtually a pristine forecast from Mike McAleenan as we progress through the countdown. 56 minutes and 42 seconds away from liftoff, and virtually no threat of weather impacting our launch attempt this evening. This is Falcon Launch Control. This is Falcon Launch Control at T-minus 54 minutes, 57 seconds and counting. Falcon 9 and Dragon have both been powered up, their systems activated, the computers are turned on. The fueling process has gone well. RP-1 propellant, which is a rocket-grade kerosene, and liquid oxygen both have been fed into the 2 stages of the Falcon 9 rocket. You can see the plume coming off of the 2 stages, signifying gaseous oxygen being vented overboard. The Falcon 9 topped with Dragon is 207.8 feet tall and 12 feet in diameter. And the 9 first-stage Merlin engines generate 1.3 million pounds of thrust at liftoff, rising to nearly 1.5 million pounds of thrust as the Falcon 9 climbs through the atmosphere. Dragon is 14.4 feet tall and also 12 feet in diameter. The trunk is 9.2 feet tall, and with the solar arrays fully extended in orbit, it measures 54 feet wide. Everything is progressing well toward a scheduled liftoff at 1:52 and 3 seconds a.m. Eastern Daylight Time. This is Falcon Launch Control. This is Falcon Launch Control at T-minus 51 minutes, 41 seconds and counting. Dragon is filled with more than 5,000 pounds of supplies and payloads, including materials that are going to support the 255 science and research investigations for both Expeditions 41 and 42 aboard the space station. Dragon has 3 powered cargo payloads in its pressurized section and 2 in the unpressurized trunk. For the very first time, Dragon is carrying live animals, 20 rodents riding up in the NASA Rodent Research Facility developed by scientists and engineers at NASA's Ames Research Center. The rodent research system enables researchers to study the long-term effects of microgravity on their physiology. Other science payloads include the ISS Rapid Scatterometer, the Special Purpose Inexpensive Satellite, or SpinSat, and the 3D Printing in Zero-G technology demonstration. The 3D Printing in Zero-G is going to use relatively low-temperature plastic feedstock to demonstrate that a 3D printer works normally in space, the first step toward establishing an on-demand machine shop in space, a critical enabling component for the future deep space crewed missions and in-space manufacturing. The Jet Propulsion Lab in Pasadena, California developed one of the signature experiments for the station, the ISS Rapid Scat. The device is flying inside the trunk section of the Dragon and will be connected to the outside of the station's Columbus module, which will give it an unobstructed view of the Earth more than 200 miles below. From there, it will study the ocean winds on Earth and track hurricanes and storms. And we have a video that explains a little bit more about RapidScat that we'll play for you now.
Seeing things like a hurricane develop in its earliest phases, getting a much better idea of its strength than we can from flying one or two planes through it. We can map the entire surface effect of a tropical storm in one pass. The ISS RapidScat is a mission to bring a payload to the International Space Station, and from there we will observe the Earth's oceans and be able to map the speed and direction of winds near the surface.
RapidScat is a scatterometer. It's a radar. It sends out little bits of energy towards Earth's surface that then get reflected back.
If the ocean is flat, most of that energy from the radar just scatters away.
The stronger the wind, the rougher the surface will be, the more energy will be returned to the radar, and then we can convert that energy into a measurement of the wind.
And that'll help us do things like track and predict severe storms, and also learn about the ocean-atmospheric interface.
Especially over the tropical regions, which are of great interest to the United States, because most of the tropical hurricanes that hit the United States come from those regions.
We're launching on a SpaceX Falcon 9 rocket.
The Dragon capsule separates from the Falcon 9 in orbit.
And after orbiting Earth a couple of times, the International Space Station robotic arm reaches out and gently grabs the Dragon as the Dragon, slowly approaches the ISS.
About 2 days later, ground controllers bring the robot arm over.
The robotic arm then reaches into the trunk and grabs the instrument and plugs that onto the International Space Station.
And everything mates robotically. We hook these pieces together, and then we get to stay on the outside of the space station for a couple of years. The space station came and asked what relatively inexpensive payloads we could put up on the space station.
We had this hardware sitting there doing nothing, collecting dust for the last 13 years. We might as well try to put it to use.
What if we took some of the existing hardware and tried to fly it in the simplest way possible?
We've put them through extensive testing, electrically tested them, vibration tables, thermal vacuum chambers.
And that leftover hardware meant that we got to save about 80% of the cost in terms of being able to reuse the hardware instead of building new.
And we've added the necessary adjustments needed for this new orbiting platform that we'll be on.
The space station is built out. We know what the external capabilities are. We know we can put science instruments in different places.
We're taking something with a very small team, a very small budget, and a very short schedule, and turning it into something with very real science value.
The global coverage of the Earth is probably right now one of the greatest priorities that people should have in mind when they think about the importance of the space program.
The Earth is a very dynamic, very complex system. And because of the role that winds play, it's a fundamental part of that whole story.
And we need people's awareness and understanding of the importance of NASA's mission to help understand how our climate is changing.
We're 46 minutes away from the scheduled liftoff of Falcon 9 with Dragon. One of the important milestones upcoming in the countdown at T-minus 27 minutes. Dragon will go to internal power. Final launch preparations will begin at T-minus 20 minutes. And a readiness poll will be conducted about 13 minutes away from launch. The terminal countdown begins at T-minus 10 minutes, at which point all systems will be autonomous. At T-minus 2 minutes and 30 seconds after polling Mission Control in Houston and the launch team at the SpaceX Mission Control in Hawthorne, California, the SpaceX launch director will give a final go for launch. About a minute before launch, the flight computer will be activated. 55 seconds before liftoff, the pad's water deluge system will be activated. 3 seconds before liftoff, the 9 Merlin engines of the first stage will be commanded to ignite, and if all goes well, T0 will occur at 1:52 and 3 seconds a.m. Eastern Daylight Time. Again, everything is proceeding well. There are no major technical issues. Weather is 90% go. Not expected to be an impact this morning. This is Falcon Launch Control. This is Falcon Launch Control at T-minus 43 minutes, 38 seconds and counting. And a number of the investigations that we've been talking about on this mission have been brought forward to NASA by the Center for the Advancement of Science in Space, or CASIS, a NASA partner. And we have a video that elaborates on some of the science and investigations that will be going up with Dragon to the International Space Station.
Our country has many national labs covering a landscape of scientific disciplines. The ISS National Lab is the newest of our nation's labs, and we can study things in space that we just can't study here on Earth. ARC-2 is our second suite of projects going to the International Space Station, with drug development, materials science, all the way into the life sciences where we could improve human wellness here on the planet. On this mission, we're going to launch a very interesting new piece of hardware that will significantly enhance our capability to conduct rodent research.
Now that the space station is complete, we can move into the utilization phase. And so NASA came to us and CASIS came to us and said, look, this would be a great tool to be able to study bone density in microgravity. Can you develop it, and can you develop it quickly?
Until you get world-class hardware, you can't do world-class science. So what we're doing is we're enabling capabilities that they never thought possible on the space station.
A bone densitometer basically measures the amount of bone loss that the mouse will see up in microgravity. So if the goal and objective is to try to cure osteoporosis, think about it. If we have accelerated bone loss in space, and we have a control group of animals and a group that we implant with a drug, and we compare the two, we can see, is this drug effective at reducing or eliminating osteoporosis in the bones? Osteoporosis is very widespread, and I think this technology has a potential to have a huge impact on just the health and well-being of the older population.
The more experiments we get into space, the more public that is, the more people are going to realize that, hey, this is a very unique opportunity.
So many people have put blood, sweat, and tears to get the space station built. Now, let's make some great discoveries.
10 years ago, NASA was focused on completing the construction of the International Space Station. Now we're in the utilization era, and so we're trying to attract those innovative, non-traditional users.
Cobra has a long history of developing new technologies and being some real game-changing moments. From the very first baffler product in 1975 to putting graphite shafts in metals. We have to come to market with the right product. We cannot come to the market with something which is inferior. It has to be bigger and better and stronger than the previous model that we have. And this is just the next chapter.
Cobra Golf R&D is working with CASIS to put an experiment on board the International Space Station that's going to investigate plating characteristics on metals to determine if we truly can make a better product. I would say almost anything that is made, anything where you'd like to be able to make a much more complex structure that you can't make here on Earth, huge leaps can be made in that environment.
Not only can Cobra Puma Golf learn something in microgravity about their golf clubs, but they also can take advantage of our seal, Space is in it. The Space is in it seal is a logo created by Cases that identifies the value of using this new environment to improve a product line or a service.
It's just flat out cool, and people understand that it's super high tech. And if you look at the golf club and can imagine all of the stuff that it's taken to, to get us into space is in that golf club, from a branding standpoint, I can't see a better fit. I really can't.
People have always been fascinated with space. It's the unknown. From the very first days of trying to put a man on the moon in the late 60s through to the International Space Station as it is today.
This is an exciting period of time right now where we have the opportunity to join with non-traditional users, not just researchers, but commercial for-profit companies to improve life on Earth and ultimately benefit mankind.
"38 minutes and 30 seconds till liftoff of the Falcon 9 and Dragon. Live from Cape Canaveral, Florida at the Cape Canaveral Air Force Station at Space Complex 40. Weather virtually pristine again this evening. The launch control team is not working any major technical issues. This is Falcon Launch Control.
OSM, this is LC on the countdown net.
OSM.
Can you move to net A real quick?
Roger.
This is Falcon Launch Control at T-minus 35 minutes and counting. About 10 minutes after launch this morning, Dragon will reach its preliminary orbit. It will then deploy its solar arrays and begin a choreographed series of thruster firings to reach the International Space Station. After a 2-day trip, Expedition 41 flight engineer and European Space Agency astronaut Alexander Gerst, with assistance from NASA astronaut and flight engineer Reed Wiseman, will be using the International Space Station's 57.7-foot robotic arm to reach out and capture Dragon as they operate from the space station's cupola. Grapple is planned for Tuesday, September 23rd at 7:04 a.m. Eastern Time. And about 2 hours later, ground commands will be sent from Mission Control in Houston for the station arm to install Dragon on the bottom side of the station's Harmony module for its stay at the station. By the next day, the crew will pressurize the vestibule between the station and Dragon and will open the hatch that leads to the forward bulkhead of Dragon. Over the next 4 weeks, the crew will unload the spacecraft and reload it with cargo to return to Earth. Dragon is currently scheduled to return to Earth in mid-October for a splashdown off the coast of Southern California. About 5.5 hours after it departs the station, it will splash down in the Pacific Ocean about 380 nautical miles off the coast of Baja, California. Dragon is the only space station cargo craft capable of returning a significant amount of supplies back to Earth, including experiments. On this flight, it will return about 3,800 pounds of cargo, including crew supplies, hardware, and computer resources, science experiments, space station hardware, and 4 powered payloads. Everything proceeding normally on the countdown this morning. 32 minutes, 52 seconds away from liftoff. This is Falcon Launch Control. T-minus 30 minutes and counting. Everything proceeding normally for the liftoff of Falcon 9 and Dragon at 1:52 a.m. This is Falcon Launch Control at T-minus 27 minutes, 15 seconds and counting. Standing by for Dragon to go to internal power 27 minutes before liftoff. The voice circuits from the various disciplines monitoring the spacecraft and launch vehicle today are very quiet as everything is proceeding normally. Weather has cleared. There still remains a 10% chance of violating the cumulus cloud rule, although all of the clouds that have been forming in the area have been dissipating prior to reaching the zone around the launch area. So we're not anticipating weather to be a problem. Very quiet, everything proceeding normally at T-minus 26 minutes and counting. This is Falcon Launch Control. T-minus 24 minutes and counting. The launch control team will begin final launch preparations 20 minutes before liftoff. Everything again proceeding normally.
Okay, see you on countdown 1. I polled the team, and we're good to go into terminal count.
SpaceX Chief Engineer Hans Koenigsmann informing the team that he has polled the team of flight controllers and they're ready to go into the terminal count. T-minus 22 minutes and 44 seconds and counting. Teams of engineers at Hawthorne, California, and here at Cape Canaveral, Florida, overseeing their systems in preparation for launch, 22 minutes away from liftoff. Scott Stover's team of flight controllers at Mission Control in Houston, awaiting liftoff and the beginning of the journey of Dragon toward the International Space Station. T-minus 21 minutes and counting.
OSM, can you verify the flight hazard area roadblocks have been established?
They have been established.
CE, can you set the warnings phase to terminal count?
Setting to terminal count. And complete.
T-minus 19 minutes and counting, and all systems remain go. T-minus 18 minutes. T-minus 16 minutes and counting. The SpaceX Falcon 9 rocket at Space Launch Complex 40 at Cape Canaveral Air Force Station, primed and ready for liftoff at 1:52 a.m., fully fueled with RP-1, kerosene, and liquid oxygen. The Dragon spacecraft powered up. All systems go on both the spacecraft and the rocket. We'll be standing by for a readiness poll at T-minus 13 minutes.
T-minus 15 minutes. All personnel stand by for the final poll at T-minus 13 minutes. T-minus 14 minutes.
T-minus 13 minutes, 19 seconds and counting, and standing by for a final readiness poll from SpaceX Launch Director Ricky Lim, statusing all the controllers on their go, no-go for launch.
All stations verify ready for launch. All stations acknowledge. FTS.
FTS go.
Prop.
Prop go.
AVI.
AVI go.
GNC.
GNC go.
Ground.
Ground go.
Vehicle controller.
VC go.
Ground controller.
GC go.
Range coordinator.
Range coordinator go.
OSM.
OSM go.
ROC.
ROC go.
CE.
Go.
MD.
Dragon MDs go.
LD, verify we have a go to initiate terminal count.
Initiate terminal count.
Copy. Just a reminder that today's plus count callouts will be performed per procedure 3.170.
So everyone go for launch. We're at T-minus 12 minutes, 10 seconds and counting. The terminal countdown will begin at T-minus 10 minutes.
T-minus 12 minutes. VC and DC, start the terminal count auto sequence set to start at T-minus 10 minutes.
Copy. Terminal count auto sequence started.
Dragon terminal count auto sequence has started.
Copy. If a hold is called from this point forward, the terminal count auto sequence will be aborted. Indicate an abort or hold condition by saying hold, hold, hold on the primary countdown net. In this event, the VC will immediately abort the auto sequence. The VC shall not abort the auto sequence after T-minus 10 seconds, and operators shall not call a hold after T-minus 10 seconds. If a hold is called, all operators proceed to the terminal count abort steps in section 10.64. Attention all personnel, stand by to pick up the count. T-minus 10 minutes and counting on my mark. 3, 2, 1, mark. BC, verified auto sequence has started.
Terminal count has started.
GC, VC, stand by on FireX.
Standing by. Standing by.
RC, start the tracking camera video recorders.
Recorders started.
OSM, set launch enable to flight.
Flight. Pre-valves open, starting M1D chill.
T-minus 9 minutes and 30 seconds, and all continues to go well. The next major milestone.
Setting up.
The next major milestone, the flight termination system will go on internal power 3 minutes and 15 seconds away from launch.
T-minus 9 minutes. T-minus 8 minutes. ACS closing out.
All systems remain go for an on-time launch at 1:52 a.m.
Stage 1 heaters closing out. T-minus 7 minutes. Stage 2 heaters closing out.
T-minus 6 minutes, 30
F9
seconds.
switching to internal power and ground TVC system setting up. T-minus 6 minutes. Pressing up tanks for strong back lower.
Vehicles on internal power.
Both Falcon stages are on internal power, preparing to lower the strong back. T-minus 5 minutes, 33 seconds and counting.
Final M1D fuel bleed started. Upper cradle opening. T-minus 5 minutes. Starting in back TVC motions.
T-minus 4 minutes, 30 seconds and counting. The strong back
motion started.
Strong back rotating away from the Falcon rocket.
T-minus 4 minutes.
Pad and vehicle abort system setting up.
T-minus 3 minutes, 30 seconds.
FTS is on internal power.
Flight termination system on internal power and preparing to be armed.
T-minus 3 minutes.
FTS is armed.
LOX loads closed out.
Launch Director Ricky Lim preparing to verify the team is go for launch.
LD, verify go for launch.
SpaceX, Falcon 9, and Dragon are go for launch.
T-minus 2 minutes, 20 seconds and counting. Standing by for the range control officer to verify that the eastern range is go.
Rock, verify range go.
Range green.
All systems are go. T-minus 1 minute, 45 seconds and counting.
Helium is closing out. T-minus 1 minute. F9 is in startup. DC, verify Dragon is in startup.
Dragon is in startup.
Stage 2 pressing up to flight levels.
T-minus 45 seconds and counting.
T-minus
30 seconds.
T-minus 20. T-minus 15. T-minus 10. 9.
9, 8, 7, 6, 5, 4, 3, 2, 1. Engines ignited. And we have liftoff of SpaceX Falcon 9 rocket and Dragon. CRS-4 is underway. A U.S. commercial spacecraft launching from American soil delivers new science and technology to the International Space Station.
First stage propulsion performing nominally.
At 1 minute, 13 seconds after liftoff, the Falcon 9 will reach supersonic speed, passing through the area of maximum aerodynamic pressure. 10 seconds later.
altitude 5.8 kilometers, speed 250 meters per second, downrange distance 0.8 kilometers. Vehicles flying down the nominal. Vehicles reach maximum aerodynamic pressure.
First stage for propulsion is still nominal.
Power system still nominal. Telemetry log solid.
One minute, 55 seconds into flight of Dragon. And all systems performing well on the Falcon.
MVAC chilling has begun. T plus 2 minutes, 10 seconds. Altitude 38 kilometers, speed 1.16 kilometers per second, downrange distance 19 kilometers.
Standing by for first stage cutoff, main engine cutoff, 20 seconds from now.
T plus 2 minutes, 30 seconds. Altitude 61 kilometers, speed 1.9 kilometers per second, downrange distance 40 kilometers.
Stage separation confirmed.
And we've had main engine cutoff and stage separation.
And we have MVAC ignition.
The second stage single Merlin vacuum engine has ignited.
3 minutes. Altitude 93 kilometers, speed 2.12 kilometers per second, downrange distance 79 kilometers.
This will be about a 7-minute burn, bringing Dragon into low Earth orbit. Fairing jettison.
Stage 2 propulsion is nominal.
Stage 1 and Stage 2 power system still nominal.
T plus 4 minutes, 25 seconds. Altitude 156 kilometers, speed 2.5 kilometers per second, downrange distance 193 kilometers. Acquisition signal, New Hampshire.
Five minutes, 20 seconds after launch. All Falcon systems continuing to deliver as expected. About 4 minutes before second stage engine cutoff.
Stage 2 propulsion is still nominal.
T plus 6 minutes 20 seconds. Altitude 202 kilometers. Speed 3.7 kilometers per second. Downrange distance 420 kilometers.
Nominal telemetry on both stage 1 and stage 2.
3 minutes remaining in the stage 2 burn.
Stage 2 prop is still nominal.
Seven minutes, 30 seconds into flight.
T plus 7 minutes 30 seconds. Altitude 210 kilometers. Speed 4.7 kilometers per second. Downrange distance 610 kilometers.
"90 seconds remain in powered flight. "8 minutes, 45 seconds into the flight of Falcon 9 and Dragon. Standing by for second stage engine cutoff in 34 seconds.
FTS has been saved.
T plus 9 minutes. Altitude 207 kilometers. Speed 6.7 kilometers per second. Downrange distance 925 kilometers. Vehicles and terminal guidance. Engine cutoff.
Engine cutoff as planned. 30 seconds away from Dragon deployment.
Orbital altitude at insertion 359 by 199 kilometers. Incline 51.644 degrees to the equator.
Newfoundland acquisition of signal.
Dragon separation confirmed.
And Dragon is flying free. On its way to the International Space Station. Due date, Tuesday, 7:04 a.m. Eastern Time. We'll be standing by for solar array deploy. 12 minutes after liftoff. Now we're watching the beginnings of solar array deploy.
Lost signal at the New Hampshire tracking station. Continue to receive excellent data from the Newfoundland tracking station on second stage.
So with the solar array deploy from Dragon and a team of flight controllers at Hawthorne, California from SpaceX, eagerly awaiting the transport of Dragon to the International Space Station, we will conclude our launch coverage of the launch of Falcon 9 and Dragon on the SpaceX CRS-4 mission. Once again, Dragon will arrive at the station on Tuesday. NASA television coverage will begin at 5 a.m. Eastern Time for an expected grapple at 7:04 a.m. Installation will begin at 9 a.m. Installation coverage on NASA television, with the berthing occurring at approximately 9:15 a.m. We will be holding the SpaceX CRS-4 post-launch news conference at 3:30 a.m. Eastern Time at the Kennedy Space Center press site and on NASA television. Thank you very much for joining us, and we will leave you with replays of today's successful launch of SpaceX Falcon 9 to begin the CRS-4 mission. This is Falcon Launch Control.